here. Yeah, that's okay. And let me. So Per Peterson is professor and chair of the Nuclear Engineering Department. Per's research includes work on high-temperature reactors and the processing of nuclear waste. His work in the 1990s contributed to the design of passive safety systems for the so-called Generation 3+ reactors, and he has since been working on plans for Generation 4, so we're very happy to have him here.
Thank you. And if it sounds like the microphone works, I've been told I have 5 minutes. I will try to provide a brief introduction to what has happened to the nuclear power plant at Fukushima. It has 6 reactor units, 4 of which were damaged substantially as a consequence of the tsunami. This is a photograph from inside the control room of units 1 and 2. And the interesting point is that the earthquake, while being stronger than the plant had been specifically designed for, was actually not strong enough to disable the safety systems. And so the plant had shut down and its emergency diesel generators had stopped. The off-site power had been disrupted because of the earthquake. But the emergency core cooling was active and the situation was stable until the tsunami arrived. There will be some discussion of what that tsunami was like, but the reports that we have now indicate that it was probably about 15 meters tall at the location where it hit the plant. The spray actually went over the roof of the building, and these are large buildings. This is the set of units right here. The most important consequence from the tsunami was that it disabled the emergency diesel generators, causing what's called the station blackout, and it caused widespread devastation around the plant, which created large delays in the capability to hook up replacement power sources and to bring in fresh water. And so the operators were forced, therefore, to rely on battery power and non-passive or only partially passive systems to provide cooling to the core. And after many hours of operation in each of the units, their capability to provide adequate coolant injection into the cores was degraded, and therefore there was overheating and substantial damage to fuel. Now, because these are light water reactors, the design of the containment was such that most of the radioactive material that was released from the fuel was actually retained inside the containment. And you can see that the releases were actually very small, except at points in time when the operators had to vent the containment to release steam to cool down the system because they had no external source of energy to provide cooling to the containment. Then there were some larger releases, but still involving small fractions of the volatile fission products that occurred out in the time frame of March 15th, 16th, and 17th. Since the 19th, there's not been any additional substantive releases of radioactive materials, and therefore the radiation levels around the plant have been dropping largely since then. At this point, we think that it's possible that the damaged fuel has been stabilized inside the 3 reactors. There was also some initial concern that the spent fuel pools were going to boil dry and that there could be releases from spent fuel. At this point, it appears that the spent fuel pools are all on the path to being refilled and that there will not be any substantive additional damage to spent fuel, if indeed there was any to begin with. And it also appears that, at least for now, that the cores have been stabilized in a coolable geometry, and that as long as coolant continues to be injected, that they will remain stable. So at this point, we may be transitioning over the coming week into efforts to mitigate the accident from the perspective of first of all, flushing out some of the highly radioactive fluids that are in the reactor vessel and the dry well to clean those up, and then to recover core debris and spent fuel from the spent fuel pools, and that's where things will be going forward. I'll conclude with that. And then I should apologize. I've been very, very much fixated. I was on a plane back from the East Coast at 1:30 this morning, so if I'm not completely coherent, it's purely from lack of sleep. There's a sister plant to this at the Millstone site that's essentially identical. And yesterday I was walking through that plant. The plants that we have in the United States, and particularly in California, have substantially different design from these plants. So the main thing that's going to happen is a systematic review to make sure that they have the capacity to sustain system blackout, that is, to provide adequate cooling and shut down after they might lose emergency diesel generators, and then a review of other lessons that have been learned here. For example, the fact that the systems for venting hydrogen did not function properly in the absence of power, leading to the explosions and the destruction of the secondary containments in these buildings. That will be reviewed. The specific designs of these systems in the U.S. plants are substantially different. So this will be more of a generic review to assure that all lessons that can be learned from this accident are applied and taken into account in the plants in California. I think there will be others that will be discussing the nature of the seismic and tsunami threats that we have in California and how they would compare to those in Fukushima, so I won't go into that part of it. And I'll be happy to take questions, of course, during the panel session.